Yeah, today would be parallelograms. We're going to look at the definition. The definition, as I mentioned, a parallelogram is a quadrilateral four-sided figure and it has both pairs of opposite sides parallel with both pairs of opposite sides parallel. Parallel. Okay, so if we're looking at this as a parallelogram, then this side would be parallel to this one, and this side, I'll give it a double here, will be parallel to this one. I'm going to name it, give it a special name here. Gold. Yeah, gold. Parallelogram gold is.
The middle hypotenuse.
Yeah, this one is our diagonal. I'm going to be talking about that as well. So let me give you a chance to draw this if you've not already done so. Go ahead and draw a parallelogram and then I'll give you some properties pertaining to it. Okay. There are about 7 properties, and I'd like to even give you some area properties concerning this as we start. Alright, what I'm going to do is I'm going to compare 2 triangles. This triangle here, GOL, I'm going to compare it with triangle GDL, and you'll remember some of these features. Let's see what we've got. As we compare these 2 triangles, very quickly we'll see that this angle here, angle 1 and angle 2, they bear a certain relationship. I wonder if someone could tell. Angle 1 from this triangle and angle 2, they're what? Excellent. Alternate interior angles, so these would be the same. Alright. Similarly, angle 3 from this lower triangle will bear a relationship with angle 4 from this one. And they also, as you know, would be alternate interior angles, so they're the same. Why, you might say? Because parallel lines cut by a transversal. Transversal will be like this diagonal here, GL. You're going to have alternate interior angles congruent. And finally, as we compare these 2 triangles, I'll be able to say that the diagonal GL from this triangle is the same with the diagonal GL from this lower triangle. And so these 2 triangles are identical twins, this one with this one. I wonder if someone can remember what would be the postulate. Is it going to be side angle side, side side side, angle side angle, or what? Abby?
Equal side angle.
Yes, angle side angle. Yes, angle side angle. So once that happens, then listen carefully now. Matching parts would have to be congruent. So since these 2 triangles are identical twins, then angle O from the upper triangle, I'll give it 3, would have to be the same as angle D from the lower triangle. I wonder who can tell me why. You remember CPCTC? Can you remember that? These are matching parts of congruent triangles. So once we've got congruent triangles, then the other matching parts must be the same. So, first property. Property number 1 is that opposite angles of a parallelogram are congruent. So let's write that. Opposite angles. You can just abbreviate that. Of a parallelogram. And I'll give you the abbreviation for parallelogram right away. Parallelogram. Sorry, the sign or the symbol is just kind of a little parallelogram like this. If you ever want to abbreviate or write a symbol for it. They are congruent. They always are congruent. So not only angle O and angle D will be congruent, but this whole angle L here would be the same or congruent to this angle G. So that's the first property. Additionally, as we compare the triangle here, GOL with triangle GDL, we're going to find that since they're identical twins, this side, 1, 2, 3, GO is going to be the same as DL. Who knows why? CPCTC, yes?
Is it parallel?
Well, because the triangles are identical twins, then matching parts must be the same. So GO must be the same as DL, yes?
Yes.
All right. So we have, I'm going to say opposite sides. Opposite sides of a parallelogram are also congruent. That's a second feature. Opposite sides are congruent. And by the way, GD would have to be the same as OL also, although I didn't mark it. Okay? What else can I come up with concerning a parallelogram? Maybe I'll have to redraw and show you another feature. Let's take, see if there's anything else I'm missing. Let's take another parallelogram. Let me just draw one real quick here. Yeah, let's just draw another one that I need. See if I can do it like this. I can. Take a look at this parallelogram, which I'm trying to draw there. All right. Since, let me get my pen back. Let's see. Is that it? The pen?
The left to that.
Here?
There you go.
Let's see. All right. Since this is parallel to this, and now this will be like a transversal coming through here. Let me just extend this. We have parallel lines. Oops. Parallel lines cut by a transversal. There's a certain relationship between these two angles, this one and this one right here. Let me see if someone can remember that. Grant?
Consecutive interior.
Consecutive interior angles. So concerning a parallelogram, I can say that consecutive angles are supplementary. So that's what I'm going to write here. Consecutive angles are supplementary. I'm going to give you a few more which I will not prove to you, but going back to this one, I could have another diagonal which I, see if I can show it. Yeah, another diagonal from, let's say, O to D. And the diagonals always bisect each other. So this right here, let's say 4, will be the same as this over here. And this diagonal will be divided such that we got 5 there, and I know it's crowded here. The diagonals bisect each other. I'm going to write that for you. The diagonals, and that's provable, by the way. Diagonals bisect each other. I think I can put too much more on that diagram. Let me go to another one so I can give you some more properties. Let's see what I got on the other page. Got a couple from the worksheet. Let me give you another one. and that would be pertaining to rhombuses or rhombides. Anybody know what a rhombus is? Well, let me draw one. Rhombus would look something like this. It is a parallelogram, a special kind of parallelogram. Just take it out a little bit, and then like that. So, not quite, but anyway, rhombus, or as one of my students like to say, rhombi plural. If you got a rhombus, what's going to happen is that the four sides are the same. Does that remind you of anything? Maybe like a square, but it doesn't have to have the four corner angles being right angles. So a rhombus is a parallelogram where the four sides are the same. So let's say a parallelogram with four congruent sides. All right. A rhombus is kind of like a square because a square has four congruent sides. So if you think of a square, let me put a square beside it. And you can draw a square off to the right because I'll talk about that a little bit. Where did I go again? Okay. Yeah, let me put a square beside it.
No, there's a square option. Pick a square.
I could. Yeah, let's just probably easier. Yeah, let's just put it right here. Thank you. Let's take it right here.
It's a rectangle.
Oh, it's a rectangle. Anyway, do I have another one? Let's see if we can get one.
You could,
Oh, right here maybe, right?
yeah.
All right, let's see. Yeah, that's better. All right, yeah, let's talk about, I'll mention rectangles also. But if we have a square here, obviously the four sides are the same, but it's different from the rhombus in that the four angles will be 90 degrees. So this is a square right here. And this is the rhombus, which is a little bit different. Now, if I take the diagonal of the rhombus, which I'll go back and maybe draw it a little bit nicer. Take a diagonal here. Take a diagonal here. You can even see it. The diagonals there, they not only bisect each other, but they're perpendicular. Okay, and I'd like you to see that. So I'll give you a property concerning that. I think the diagonals of a rhombus or square they are perpendicular, and I'll abbreviate like that. Now I notice you're not taking any notes now. Okay, that would be the same for the square. If you drew diagonals for the square, they would be perpendicular as well. Okay, so that's just picking up a little bit extra. This would be, got it all together, Nick.
Okay.
All right, Tony. All right. So not only the diagonals bisect each other like this, but they're also perpendicular. Okay. Concerning a square, one more thing. Let me just go back to the square and show you that it's different from the rectangle. For the square, if I take a diagonal here and one here for this square, those would also be perpendicular. Doesn't look like it, but they're perpendicular because every square is a rhombus. So really, yes, every square is a rhombus. Every square got four sides the same, but would every rhombus be a square? No. The rhombus can be kind of tilted like this. All right. How about the rectangle? Would every rectangle be a square? No. Although the corner angles are 90, every one is not a square. Okay. Would every square be a rectangle? Could be. Could be. We'll talk about that. But anyway, I'm gonna I think I'm gonna stop it right here and give you a worksheet. You can